Hello everybody, both in the room and online, and perhaps even people that are watching this as a recording at a later date. I'll start off by introducing myself. My name's Steve Hill. I'm the Chief Scientist at Geoscience Australia, and I've been asked to chair or MC this fantastic event that we're all part of today. And this is part of Geoscience Australia's public talk program, but particularly to recognise Earth Science Week. I'd like to welcome not only the Geoscience Australia staff, but our wonderful visitors that have come both to Geoscience Australia in person, but also those that are online or watching a recording. In particular, we have a team from NEMA, which is the National Emergency Management Agency. Great to see Joe, Rebecca and David in the room here. Well done. And then we also have some colleagues from the ACT Emergency Services, and we'll introduce them shortly because they're going to be part of this presentation as well. But great to have you join us and be part of this event. Thank you. Before we go any further, I'd also like to acknowledge that Geoscience Australia values the lands, water and sky as we work to deepen our shared understanding of country and earth. We respect First Nations peoples and their enduring connection, contribution and obligations to country. Reflecting on our shared history, we are committed to listen and learn. And I love the way that we really do value that working together and learning together about this amazing country that we're part of, this part of the planet. So, today, for Earth Science Week, we're going to highlight earthquakes. So much happens with the Earth. The Earth is so dynamic. Earthquakes are a really important part of that, and particularly because they impact on our lives. We're going to consider how they happen and what we know about them, and then what to do if you ever find yourself in one. We'll be hearing from Michelle and Ben from Geoscience Australia, as well as Damian and Sam from the ACT Emergency Services Agency. And we'll, as I said, we'll introduce all of them later. My job is to get things started and introduce you all firstly to Earth Science Week, and that's what I'm going to do right now, and just share a few slides to explain Earth Science Week and why that's important to everyone. Okay, so Earth Science Week is held in October every year. It's great because it sits separately to National Science Week. National Science Week is also a focus that we have at Geoscience Australia, but we do tend to find that in National Science Week there's a lot of competition for everyone to look at the wonderful science that's going on. And we find that Earth Science Week is a great opportunity for us to be able to really stand out and take a strong leadership role and be able to get a lot more attention around the importance of the science of the Earth. Earth science impacts our everyday lives, from switching on a light to turning on the tap, and the much used example of even ordering a pizza requires the science of the Earth to be successful. Earth science has a critical role to play in Australia's future, and this year we're encouraging everyone to join us in celebrating the theme Earth Science Everywhere. And indeed it is everywhere. It gives us the resources that we use every day. It helps us understand natural disasters and how to prepare for them. It's also important to inform the management of natural resources, and it plays a role in urban planning to build safer, sustainable communities. So that's a little introduction on Earth Science Week, that week where we really celebrate the science of our planet and how we live with it. Let's now get into our fantastic presentations. And first up, I'd like to introduce Michelle Salmon. So Michelle is a senior duty seismologist at Geoscience Australia, and she's responsible for bringing in high quality, near real-time data from across the Australian National Seismic Network to provide time-critical data to our stakeholders, many of whom are in the room. She also provides 24/7 seismologist support and advice to the duty staff in the National Earthquake Alert Centre, also known as NEAC. We love a good acronym in government, so get ready for it. And assists in disseminating earthquake information to the public through the media. And that's actually been something that you've been very busy with even this morning. Michelle, please share with us your presentation.
So, I'm here to talk about earthquakes. I think that many Australians are surprised to learn how often our continent shakes. This map actually shows the past 50 years of earthquakes, magnitude 3 and greater. There are more than 6,000 events on this map. On average, that's more than 100 earthquakes a year. While most of these occur in remote regions and people don't necessarily feel them, the shaking from a magnitude 3 earthquake can be felt locally. But we also have 2 to 3 magnitude 5 earthquakes annually, and a magnitude 6 earthquake around about every decade. And even now, every now and then, one of those larger earthquakes hits somewhere close to where people live, which is why knowing what to do is so important. And tomorrow is the Great ShakeOut Day, and I hope that you will join us in an earthquake drill. So I want to actually take a look at a few significant earthquakes just to show you some of the impacts that can happen. Yesterday was actually the 57th anniversary of the 1968 Meckering earthquake. It was a magnitude 6.5, and the shaking was so violent that much of Meckering was flattened. The images you see next to the map show the devastating impact on unreinforced masonry buildings and critical infrastructure. The lower left image shows the ground rupture, which cut across a road, which was more than 30 kilometres long and more than 1.5 metres high. The scar can still be seen today. The earthquake actually did damage as far away as Perth, so that was around about 150 kilometres away. But the legacy of Meckering goes beyond just the destruction at the time. It was the catalyst to start a conversation about earthquake resilience. And it took 11 years, but in 1979, Australia introduced its first earthquake standards for engineers. It's a crucial step for safer buildings and communities. So the next earthquake is actually Australia's largest. The Tennant Creek earthquake in 1988 was a magnitude 6.6 event. It remains Australia's largest recorded onshore earthquake, and despite this, it didn't actually do as much damage as Meckering. It is not Australia's deadliest earthquake. The town was mainly single-storey modern construction, and so there wasn't nearly as much damage. But the magnitude 5.4 earthquake, much smaller, more than a magnitude smaller than the Tennant Creek earthquake in Newcastle, takes the title as Australia's most devastating earthquake. The epicentre was close to the town centre, and the shaking was severe. Tragically, 13 lives were lost. 9 of them in the building that you can see collapsed in this picture, which was the Newcastle Workers' Club. More than 160 people were injured and 1,000 people were made homeless. The damage was staggering, with over 50,000 buildings were damaged. That included 40,000 homes, and 300 buildings had to be demolished. The financial toll was estimated at $4 billion in 1989. It was a wake-up call, not just for Newcastle, but for all of Australia. The earthquakes can and do happen here, and they can be deadly. The Newcastle earthquake reshaped how we think about seismic risk in urban areas and remains a reminder of why earthquake preparedness matters, even in places where we least expect it. So I actually work in the observatories team here at Geoscience Australia, where we make sure that the Australian National Seismograph Network keeps running to monitor earthquakes. The network shown in the map, the little green squares, there's over 100 stations in that, and it covers not just the mainland of Australia, but it reaches out into the Pacific, Indian and Southern Oceans, and even goes as far as Antarctica. This coverage actually allows us to detect earthquakes as small as a magnitude 3 across the country. The data we collect is streamed live to the National Earthquake Emergency Centre, which Ben will dive into next. Our seismic stations actually vary depending on the local conditions. We use everything from shallow seismic vaults, shown in the centre at the bottom, and we have borehole installations. You can see a big borehole instrument being lowered in on the right-hand side. Sites have two key instruments. They have a seismometer, which detects small tremors. So these are ones that you and I may not even feel. And then there's an accelerometer, which kicks in when the ground really starts to move and measures the strong shaking from larger events. These stations are usually tucked away in quiet, remote locations where they don't see the traffic and other noise that could interfere with the data. Inside the cabinet, there is real-time communication so that the data can be sent back to Canberra. And we see those seismic recordings right here in Canberra, and it's a 24/7 monitoring system, and it feeds into the national and global alert systems and research networks. So with the data that we collect, Geoscience Australia has used decades of earthquake data to produce the Australian Seismic Hazard Assessment. The location and frequency of small earthquakes can help us to understand where larger ones might occur. But we don't stop there. We also have people who go into the past and they look at paleoseismology to uncover geological evidence for ancient earthquakes. The time span between earthquakes is much longer than what we have in our seismic records, so we need to be able to go back further into the past. The map that you can see here is the Australian Seismic Hazard Assessment. It shows the expected level of ground shaking over a 50-year period with a 10% chance of exceedance. The red and yellow zones highlighted areas where stronger shaking is more likely. These maps aren't just for scientists. They're used by engineers to design buildings that can withstand that expected shaking. And that's why we hope that today, an event like Meckering, our buildings will perform much better. When a large earthquake strikes, time is critical. The faster that we can understand what has happened and where, the faster that we can respond. That's where ShakeMap comes in. ShakeMap uses live data from the Australian National Seismograph Network combined with felt reports from the public to create a rapid map of how the earthquake was experienced across the region. This image actually shows the Kilkeven earthquake that happened this year, where we received more than 20,000 felt reports. This was for a magnitude 5.6 earthquake. This isn't just a scientific tool, it can be a life-saving one. The first version of the shake map can be ready in as little as 30 minutes after an earthquake, and that means emergency services can quickly identify the hardest hit areas and direct resources where they're most needed. Okay, after a major earthquake, one of the most valuable tools we have isn't just the instruments, it's you. Your felt reports help us pinpoint where the shaking was strongest. So we would like to encourage people that when they do feel an earthquake, they submit a report on earthquakes at GA. This site isn't just a place for you to submit the reports, it's also a great resource for finding out about the earthquake you just felt and earthquakes around Australia. To submit a report, all you have to do is click the little felt report button, and you'll be guided through a set of questions, simple questions that help us understand your experience. They're questions like, where were you? What were you doing? Did others feel it too? And how would you describe the shaking? And even if you didn't feel anything, there's an option for that as well. Every report helps us build a clearer picture of how earthquakes can shake the country. And I'm now going to hand over to Ben from the National Earthquake Alert Centre, who is going to talk about that part of what we do.
Thank you, Michelle, for that introduction, and good morning, everyone. Once again, my name is Ben, and I'm the National Earthquake Alert Centre's training officer. I'm responsible for, obviously, training, but also maintaining the capability of NEAC's 24/7 duty team, who conduct rapid seismic analysis on critical events both here and Australia and provide information and alerts on those events. We're relied upon by emergency management organisations, local, state and federal government, the media and the general public. NEAC also maintains a historic record of Australian earthquakes that's used for disaster planning and research, and we're also partnered with the Bureau of Meteorology in operating the Joint Australian Tsunami Warning Centre. Michelle's just touched on seismic hazard in Australia and some of the other work that NEAC is involved in, but we also monitor for earthquakes overseas. For monitoring earthquakes overseas, we need access to information from all over the world. Australia, along with many other countries globally, provide open access to their real-time seismic data. On this map behind me, every triangle you see is a station that NEAC has access to and uses in our earthquake solutions. And the colour of those stations represents the state of health of the station or when we last received data. As you can see here, indicated by the star, on the 1st of October, we observed an earthquake in Papua New Guinea. Simultaneously, at the same time, we were observing a network outage on some of our closest stations, which is indicated by the triangles in red to the left of this event. What that functionally means is we would not have been able to locate that earthquake if we only had access to that information. But because we have access to networks both here in Australia, but also in the South Pacific and Southeast Asia, we were able to get a solution for this earthquake quite quickly. This allows for more timely and robust earthquake and tsunami characterizations within a regional setting, which is really important for the type of work we do. But why does NEAC monitor for international earthquakes? The Australian government monitors overseas earthquakes primarily to protect its citizens from the potential tsunami threat, but also for disaster response capabilities and to contribute to a global network of knowledge for community safety and resilience. Australia can also deploy disaster assistant response teams to provide assistance following overseas disasters. And although the Australian mainland is not located on a tectonic boundary, it doesn't mean that we don't feel the effects of larger earthquakes that occur in subduction zones. Notably, people in the northern parts of the country can experience these effects of these large events from places like Indonesia and Papua New Guinea. The map behind us shows the spread of felt reports we received from a magnitude 7.6 earthquake that we located in the Banda Sea on the 9th of January 2023. We received reports of moderate shaking from across the Darwin region and reports of weak shaking from parts of Queensland and Western Australia over 1,500 kilometres away. NEAC will review and publish all overseas earthquakes that have a magnitude of 5 and greater. But what happens if one of these events are potentially tsunamigenic? So on the 17th of December 2024, Vanuatu experienced a magnitude 7.2 earthquake. This triggered several subsequent hazards like landslides and local tsunamis and had devastating impact across the capital of Port Vila. So NEAC observed, or we produced a first automatic preliminary solution of this earthquake 3 minutes after it happened, which you can see is the top solution here. This solution contains very few global observations. Once an earthquake happens, time is needed to allow those seismic waves to travel around the Earth to get more observations so we can be more confident on things like depth and magnitude. So for this event, that analysts on duty would have been reviewing all information that became available from 3 minutes after the event up until 8 minutes, repeatedly introducing more information when it became available. Before origin time plus 10 minutes, a first preliminary manual solution would have been sent out by NEAC to the Bureau of Meteorology, the National Emergency Management Agency, and the public, as early estimations of magnitude indicated that this event was likely tsunamigenic and now required a tsunami threat level assessment. And this is the comparison between what we had at 3 minutes and what we have at 8 minutes when we start sending this out to our stakeholders. It has over 200 more additional observations globally that allows for more confidence in the solution and the information we're sending out. This process is then repeated every 10 minutes for the first half an hour of the earthquake as more and more of that information becomes available. The officer on duty would have also had to remain vigilant for any other earthquake occurring globally at the time, because they could have triggered a similar reporting criteria like this, or some of these aftershocks could have also been significant. This event triggered a crisis coordination task force where NEAC had to provide important earthquake-related information to the National Emergency Management Agency. And this included things like further observations on aftershocks, but also ensured that disaster relief personnel that were sent to Vanuatu understood what to do if they experienced an earthquake. If you'd like to know more about overseas earthquakes or any earthquake in general, please visit our Earthquakes at GA website. You can use the search button to search for any historic event or recent earthquakes that will show you the last week of seismic activity recorded globally. If you feel an earthquake, please let us know about your experience by submitting a felt report. I'd now like to invite Steve back up, who's going to run us through a drill on what to do if you experience an earthquake.
Okay, so just so you're aware, tomorrow is the day where a lot of people are hosting their own shakeout events. And to help guide you through this, you may, if you don't have it in your hands or your pocket, you may be sitting on it. We had these on each of the chairs. Sorry for those online, but I think these are available online through Geoscience Australia if you wanted to print your own. But they're little bookmarks that celebrate Earth Science Week on one side, and on the other, they have the instructions here. So what we're going to do is just give a demonstration up on the stage here, and this might just help inspire you for what you could run tomorrow as part of a Great ShakeOut event. So Michelle and Ben, come up. What we're going to do is, as I said, Geoscience Australia is joining millions of people around the world participating in the Great ShakeOut as part of Earth Science Week. So this is just a drill. Don't worry, Joe. You don't have to change shirts, put your uniform on or anything like that. Yeah, it's all good. So this is just a drill. So what we're going to look at is the important steps of drop, cover, and hold on. Okay? So drop. Let's do it. Drop down on your hands and knees. The ground shaking in a large earthquake may knock you over. Dropping to the ground protects you from falling, but also allows you to move about. Look at that. Yes, the crabs are invading the earth. Cover. Take cover under a nearby sturdy table or desk. This is fantastic government furniture that we have here. Covering your head and neck in particular, or your entire body if possible. I'm not quite sure. That sounds like a twister move for me, but that would be possible for some of you with greater agility, and that will protect you from falling objects that could hurt you. Okay, great. Next, hold on. Hold on to your shelter until the shaking stops. If the shaking moves your shelter, move with it. If you can't get under something sturdy, stay low and protect your head and neck with your arms. When the shaking stops, take a moment to look around for any hazards, right, before leaving your shelter. When you are safe, then visit the earthquakes.ga.gov.au website and lodge a felt report. You know about them now, you've heard about them. Felt reports will help inform important decision-making groups and people and tools like the National Seismic Hazard Assessment. This is the end of the drill. Well done, Michelle and Ben. Great work. Thank you very much for participating in that. And hopefully that inspires you with some of what you could do. You could be just like Michelle and Ben and do that. Fantastic. Now, I'd like to move on to the next part of this presentation, and this is where we're very excited to have some guests from ACT Emergency Services. Firstly, I'd like to introduce Commander Damian Holloway, who joined ACT Fire and Rescue in 2008 and has since specialised in road crash rescue. In 2018, he achieved his Urban Search and Rescue Level 2 qualification. Most recently, in 2023, Damian was deployed to Turkey as part of the Australian Disaster Assistance Response Teams, supporting the international earthquake relief effort. Damian, it's a pleasure to have you here. Welcome.
Great, thanks Steve, and thanks to Geoscience Australia for inviting ACT Emergency Services to be a part of Earth Science Week. So, as stated, I'm actually here to talk to you about urban search and rescue, which is the capability that would be deployed during an earthquake if a city suffered any major structural collapse or an earthquake disaster. Urban search and rescue has a number of different functions within it. Rapid damage assessment is the first one. That's the fast, systematic triage of structures. This allows us to prioritise where we can allocate limited resources to achieve the most successful outcomes. We have search and rescue operations. Structural shoring, which is the temporary shoring and stabilising of unstable buildings that allow for search and rescue teams to go in there and perform their operations. We also have humanitarian assistance, so that includes medical aid in-field and out-of-field, body recovery, disaster victim identification, as well as clean-up and recovery efforts. We have a national capability, so all states and territories maintain an urban search and rescue capability, but what should be understood is that in a large-scale disaster, something like an earthquake disaster, the local emergency management agency is likely to exceed its capabilities very quickly and will be reliant on other states and territories and possibly international capability to assist. So in Australia, all states and territories maintain USAR capability. They're teams of trained personnel who are equipped to deal with domestic emergencies and coordinated through national frameworks for rapid deployment. What we also have in Australia, though, is we have 2 internationally certified USAR teams. They're certified through INSARAG, and that's Australia 1 in Queensland and Australia 2 in New South Wales. Those teams, in order to be internationally certified, must maintain 300 qualified personnel who are immediately available for deployment. A heavy deployment team, which is usually required for an international response, consists of a team of up to 75 personnel. That team takes with it approximately 22 tonnes worth of equipment and needs to be fully self-sustainable for up to 14 days in country. So that's taking your own food, shelter, water. Those teams, beg your pardon, that heavy deployment will operate in 4 teams on a 24/7 basis on rotation. And they are to be deployable within 5 hours of request from country. The team consists of rescuers, paramedics, infield doctors and surgeons, structural engineers, hazardous material specialists, communication experts, logistics personnel. The equipment that we'll take with this are stabilisation gear, acoustic and vibration monitoring systems or movement monitoring systems, search cameras, concrete and metal cutting tools, heavy lifting equipment, shelter infrastructure, as well as vertical access and rescue tools. We also do take, if it's available, a K9 unit as well. My lived experience was that I was fortunate enough to assist the Oz2 team in their deployment to Turkey after they suffered a 7.8 magnitude earthquake in February of 2023. It was a rapid response. We had to provide critical support in search and rescue, as well as humanitarian aid. Due to the conditions while we were there and our length of time there, we moved through search and rescue operations into body recovery and then also into humanitarian aid. While we were there on our last night, we actually experienced a 6.4 magnitude earthquake. My experience with that was that I was very thankful that at the time of experiencing that we were in tents in essentially an open field and nowhere near the structures that we had been working with during that time. What I have for you now is just some quick pictures of the devastation that we witnessed and worked in. So on the left there, you have a very typical street that we were working in. This was a part of our initial size up when we were going and assessing buildings. The one on the right you can see has actually shifted approximately 1 metre from its foundation, but is still upright. On the left there, in the foreground of the photo, same size building completely collapsed, what we refer to as a pancake collapse. All the other buildings within the street obviously looking quite precarious and leaning over. The picture on the right sort of shows that while that building is basically toppled into a zigzag style pattern, it is still upright. So we were experiencing a number of aftershocks while we were there, and this was the sort of dynamic environment that we were required to work in. The building on the left there, approximately 5 metres shifted off its base, but still remaining upright, and the one on the right obviously in a much worse situation. Here's a building, again, between 5 to 8 stories, residential building, complete pancake collapse. Here, just one building that's collapsed between obviously 2 others, but has caused significant structural damage to both buildings either side. I'm not sure if it's visible there. You might be able to see it. There are actually some markings that have been placed in the foreground there that are international symbols that we use to determine if the building has been assessed and what casualties, whether they be live or deceased, are within that building. As the deployment went on, this work here that we were conducting, this is what we refer to as basically the delaminating of buildings. We're working with excavators here on top of and around multiple collapsed buildings for the very slow systematic removal of debris to try and open up any voids where people may have had a survivable atmosphere. We would then explore those voids. This is also where a lot of body recovery happens as well. This is the last photo here, just demonstrating that this building basically lost its bottom floor completely in the earthquake and just dropped 1 floor, but the rest of it remained upright, showing that the remaining stories above were survivable, but the story underneath would not have been. Okay, I'm going to hand over now to Steve Perillo from ACT Ambulance Service.
Good morning, everybody. Thank you for having me. My name's Sam from ACT Ambulance Service. So today I'll sort of take you through what our role would be. were something like this to happen, and I'll also just touch on some of the national arrangements that would most likely come into play were there to be a significant event. So who are we? ACT Ambulance Service, where we provide the emergency as well as the non-emergency and aeromedical services to the ACT, as well as sort of surrounding southern New South Wales. We've got 10 ambulance stations, and then we have our headquarters in Fairbairn and our training centre out at Hume. And our headquarters also houses our communication centre. So, what would our role be? Our role is to manage sort of the human side of earthquakes, and that's in sort of casualty management. So, were there to be an event that's significant enough to cause structural collapse, we'd be dealing with any casualties that come out of there. So, as we've sort of heard today, Canberra is at risk, but thankfully rare occurrences. However, there are risks of casualties and fatalities that would be placing pressure on all of our services. So in terms of planning that we've got in place, there's a whole of ACT emergency planning arrangements under the ACT emergency plan. We are the lead response agency for mass casualty incidents, and we maintain a plan that sort of sets out the frameworks to guide how we would respond to ensure we've got a coordinated response. It's important because what we would be facing is a significant surge in demand on our health services, not only in the sort of immediacy where we're dealing with traumatic injuries and sort of the immediate aftermath, but then depending on the level of infrastructure collapse, we would be looking at how do we maintain health services to the community in an ongoing fashion, and making sure we're supporting our colleagues at Canberra Health Services and ACT Health to do that. So like I said, sort of our role is to maintain the mass casualty incident sub-plan. So were this to happen, we would take the role of casualty management. So once the people, if there were injured parties being taken out of the incidents, most likely by people like Damian, we would then receive them. We would be setting up field hospitals or a casualty collecting post or similar to sort of treat and manage those casualties on site as much as possible until, like we say, with demand management, making sure that we're not overwhelming the hospitals with hundreds and hundreds of casualties all at once. So we maintain some deployable equipment out at our headquarters in Fairbairn. That's things like a surge of medical supplies. We have some field hospital tents that we would set up. I've got some pictures a bit later. And doing the making sure we're integrating ourselves into the wider response so that we've got a coordinated approach. So what is a mass casualty incident? Really is anything that generates more patients than a local resources can manage using routine procedures. So again, that goes to scale. A little shake where we don't have any major structural collapse is unlikely to cause us any major headaches, but where we've got building damage, people being injured, certainly if any of our health infrastructure was to suffer any damage, it would very, very quickly escalate, and we would be talking to Joe and his team fairly shortly after. So our response strategies, we've got our internal sort of command and control systems in place. So our duty officers, sort of our first boots on the ground to start setting up those casualty management posts and then escalating from there. Our role is in the out-of-hospital response. So we sort of have the delineation of managing any patient before they get to the hospital. And in the setting of an earthquake, particularly if health infrastructure was damaged, that could be quite prolonged. until we could get them to a place where they could be safely treated in the longer term. And so that requires us to be able to coordinate not only with Canberra Health Services operating the two hospitals, the Canberra Hospital and North Canberra Hospital, but also as with the Health and Community Services Directorate as sort of the overall stewards of the health system. And they're certainly our links into the national sphere and the supports that we can call on there, which I'll get to in a moment. Again, it's about coordination, so working with fire rescue, working with police, SES, this would be, everybody would be involved. We would certainly be calling on our colleagues across the border at New South Wales Ambulance. We maintain sort of cross-border agreements for each agency to support each other. And then we would be leaning, depending on the scale, starting to lean into through our ACT Health colleagues, leaning into the Commonwealth resources through the Commonwealth Disaster Plan. So in terms of some of the national health emergency arrangements, I know I was sort of keeping this local, but it gives some good context as to what we would be working with. So there is some national health emergency arrangements. They're coordinated under the Health Protection Committee, the Australian Health Protection Committee. Our access to that is via the through the ACT Chief Health Officer. And that would be where an incident has stretched us beyond our capacity and probably beyond the capacity of New South Wales to assist us. We would be then talking to the Chief Health Officer to look into Commonwealth support. That's all coordinated through the National Incident Centre, and there are some teams and some systems that I'll talk to in a minute that they can coordinate to help support the ACT were something like this to happen. So specifically in the health space, there's the AUSMAT team. They are, the comparison I'll draw would be the health version of DART. So they are run out of Darwin through the National Critical Care and Trauma Response Centre. So they are teams of doctors, nurses, paramedics, epidemiologists, logistics officers, and they are designed to be deployed where health infrastructure or a health setting has been damaged to the point of not being functional. One of their more recent deployments was to Vanuatu after that earthquake. They were there for a number of weeks, I believe. And so that would be something that we could potentially lean on were the incident to be so catastrophic that it's overwhelmed our local resources. So AUSMAT, just had a couple of pictures there. So like I said, they are designed to run in austere environments. They basically set up a functioning hospital in the field. They can do surgery, they can do lots of public health, infectious diseases stuff. It's pretty incredible what they can set up. That's just a diagram of something they might set up. So that's called an emergency medical team type 2. So similar to what Damian was talking about in the DART setting. This is a international standard, so it's run by the World Health Organization and the National Critical Care and Trauma Response Centre. They have that qualification of being able to deploy an emergency medical team types 1 and 2. And so you can see team leaders, medical staff, nursing, paramedics, radiographers, pharmacists, allied health, so they can send occupational therapists, physiotherapists to help people with their recovery. So it's not just that sort of immediate aftermath, it's that ongoing health system support. So on a local level, as I said, we have our Emergency Services Agency Resource Centre. That is where all of our stock, both for business as usual as well as any surges, for incidents are housed, so all of our medical consumables, and that's where our sort of emergency field hospital capability lives. I'll show you a picture in a moment. They're sort of an inflatable tent type structure that we would then kit out with medical consumables, and we would also be coordinating with Canberra Health Services to make sure we've got the staff there. They can also support us with deployment of resources. So just to finish off, that's just a couple of pictures of what it looks like. The picture on the side there, that was in an exercise training. It's sort of similar to what it would look on the outside. And then the ABC News picture there is one of the few times we've deployed them in anger. That was at the Canberra Hospital switchboard fire. I think it was in 2017. So that's sort of what it looks like were we to set something up. So that's all from me. I think I'm passing back to Steve Hill. Thanks for your time.
Well done, Sam. That was great. And Damian, thank you for sharing all your information. They were great experiences. So good on you. Thank you to both. Well, that wraps it up. Thank you for a fantastic presentation. Thanks for everyone's interest and attending. I do want to put a promotional plug in for our next public talk, and that's at 11 a.m. on Wednesday, the 29th of October. And at our next talk, we're going to look at Antarctica and seeing it from space, and how seeing through persistent cloud and darkness can unlock Antarctic year-round monitoring using this Sentinel-1 radar satellite. That's going to be a really fascinating presentation where you're going to be able to really see parts of Antarctica in ways that are not readily seen. So that's something to really look forward to. It's a group of presenters. We've got a couple from Geoscience Australia, but also someone from University of Tasmania joining that. So look forward to that one. So as I said, Wednesday, 29th of October, 11 a.m, both online and in person. Have a great Earth Science Week. And don't forget, drop, cover, and hold on. Okay, thanks everybody.